Okay, welcome back to Chapter 7 of Behavior-Based Robotics. We're going back to the basis of behaviors, the perceptual basis. So what we try to learn today is instead the relation between perception and action, and what we already learned that for behavior-based robotics that's a quite tight connection. Further, we will see that you have many sensors, and it's really important to perceive, process each of the sensors on its own, modularly. We will look that expectations will help to see the right things in the sensor stream. And we will study some representative examples in robotics, how you really can apply all this. So we would have a lot of fun ahead. So previously, we worked hard to get a lot of knowledge out of the sensors, but in principle they looked on perception in isolation. So they tried to get a world model from it, and everything with it, all the effort was put in getting a right world model, and what was used in the end of that whole world model, that was less important, because you want to have a universal reconstruction of the world. So if you look at this picture, what they want to do with stereo vision, with it can estimate the distance to the tree and able to make a complete model of that tree. And in principle that's impossible because you can never see the back of a tree. So to get the 3D, the full 3D representation of a tree while you only see one side is really difficult. So instead, in behavior-based approach, you look many times to the tree from many sides. Each time you combine all those signals, and you don't build a model from it, but you only build the reaction that you want to it. For instance, if it's an obstacle that you want to avoid it, or if it's a tree that you want to find, an attractive signal. So there are many different ways of doing perception behavior-based. One of them is that you do the perception really oriented to the actions you want to perform. So only try to perceive what you're going to use. On the other hand, what we have learned from psychology is that you see what you expect to see. So you do prediction about the future and starting to look for clues in your sensor stream on that. What's very important is your attention. If you're doing a certain job, that means you're looking for certain clues, and that gives all the focus, and that means that everything that's not important is filtered out. We also have the important class that we're working with a robot. That means that we not only get a sensor stream, but we can actively steer the sensor towards certain locations. And that's well known from if you have to recognize a person, then you see that the eyes tracking a certain pattern to recognize a person. And on the end you have perceptual classes, and that means that you combine it with a sort of objects and with actions, and you will see that perception without the context is meaningless. Okay, perception is one way king, because we see from neuroscience that a lot of our brain power is dedicated to perceiving all the central clues we get, and one of the most important one is the vision, what's divided into the ventral dorsal streams. They divided those streams in different cortical areas, and what you see is that each of those areas is specialized in certain patterns, comparable in what we're doing now with deep learning. So the first ones, the V1s, are really sensitive to edges. So there are examples of kittens that they trained in a world with only vertical lines, and if they then come to stairs, they just fall over it because they never learn to recognize horizontal streams, and vice versa. If you train them in only horizontal edges, then they walk against the legs of the tables. So what you see is that the dorsal pathway is divided in a pre-processing step where what's looking for different edges and patterns, and that's split up in the parietal cortex, in the inferotemporal cortex. One of them is very sensitive to movement, the other one is very sensitive to shapes, and you see that the pathway is split up further and further in more and more specialized areas. And that's something where with it can get inspiration for if you want to recreate such a pipeline, then you can see that you can make different modules that are sensitive to thick stripe, thin stripe, certain shapes, certain movements, and in that way recreate the two pathways. So if you not look to neuroscience, but if we look to psychology, then the most, say, influential work is the work of Gibson about affordances. And what we see is that all what we perceive is coming from evolution, and that have made sure that there is a big fit between the agent and the environment. So your sensor work only in if you're an animal living in daylight and not at night, etc., etc. So the environment and the agents are with it working together. What you clearly see is what you perceive is different if you're going to start to do a different action. And there is always a lot of work ahead, what you expect to perceive and what you actually perceive. And at the moment that there is a big difference, so no correspondence, then with it, a lot of alarm signals go off and you get full attention. So if you have a certain environment and a certain action, that means that you can determine what sort of perceptual information is needed with the affordance. And then while the action is active, you have to maintain and adapt the action based on that affordance that you can perceive. So already in the 50s, you can see that from the models of the cars, there is already studies then done. What's shown here is a vehicle on the right, and in principle, if you're driving, then you're looking ahead. But what you see is that you're mainly sensitive to the pathway that you expect the car to be driven. So if you pass a parked car, you're a little bit aware if the door goes open or closed, so that you didn't hit the door if it suddenly opens. If you see a crossing coming, then your path is getting narrower because you can expect that cars are coming from the right, and They are not on a trajectory that you collide, but close to the crossing, your paths get narrowing. And for sure, if you have traffic going towards you, your path also gets narrows. So everything with it on that path that's perceived, and everything else with it is perceived as non-safe for travel. So nicer with it worked like with it in cybernetics on the perception action loop. And what he thought is that it was not a single feedback loop, but a multiple feedback loop, and that you have the behaviors, the actions, that they were directly coupled with a reactive shunt to the world. But in the same time, there was also some memory and some model built up. And at the moment that the reactions, the expectations of those with it actions doesn't fit anymore, you can with it know that you could change some of your behaviors.